And we're back live again. Sorry about this. Sheb has just had a bit of technical problems there, but now back on. So we've had testimonials from all our sessions, and as you can see, people are really happy with the sessions that we've been running with Power BI, as you see there. Also about myself, I'm a experienced recruiter with over 16 years experience. I've been running these meetups for 4.5 years, alongside the Power BI user groups. I've been doing various other lunch and learn sessions, roundtable events, and other kinds of seminars. I'm currently heading up the Power BI, so the Rob Walters BI Data Analytics team. And if you are looking for a new role, do get in touch. Or if you are looking to recruit someone, please do give me a call. My details are below. So a quick agenda of today's event. We've got Lewis on in a couple of minutes, then Ben, and then we'll wrap up and close by 1:30. And again, please do add your questions on the right-hand side of the chat box. So about Lewis, obviously Lewis is an experienced contractor I've known for a number of years. He's MCSA qualified, and he's an expert in Power BI and the Microsoft stack. Ben is an expert in Project Online, Power BI, 25 years consultant experience. He is a very experienced trainer, and he is an MVP award winner. Also Sheb, who will be producing today's session, will also be involved with answering questions. As I said last week, Sheb is also an experienced MCSE certified trainer and Power BI architect. So just ahead of kicking off, just tomorrow night, we've got another Power BI session in the evening. That's the standard use groups session. And we've got Rishi Sapra with internal and external sharing, collaboration and distribution in Power BI around finance reporting. And then we've got Lazarus, I can't pronounce the surname, so I won't, successful enterprise rollout of Power BI. So yeah, please do tune in for tomorrow night session at 6 o'clock. I'll be there, and again, we'll be doing it via Teams. So the link will be sent via the meetup, or if you need it, please drop me a note on today's Q&A. So without further ado, we'll pass over to Lewis.
Thank you very much, Alex. Yes, we'll be passing over to Lewis in a moment, as soon as I get your screen content. And Lewis, you will be live in 3, 2, 1.
Good afternoon, everyone. For those that weren't at the session last week, my name is Lewis Holmes. I'm a business intelligence consultant, specialist in the Microsoft BI stack particularly, so that's SQL Server analysis services, reporting services, integration services, Power BI. I've been using all that stuff for around 10 years. And so hopefully I've got some experience that is good to share with you guys. The example I'm going to show today is how to use parameters inside Power Query to streamline your data flow and to ensure you only get the data you need inside your Power BI model. The data I'm going to work with today is from the Internet Movie Database, IMDb. I chose this as it's quite a big data set, so it's kind of pertinent, and it's a bit more interesting than some of the other stuff that we use as examples. So if you were to go on the IMDb website to this interface's URL, it details 7 different files you can download from them, and each of these 7 files have lots of different properties. They detail all the movies, TV episodes, actors, directors, the ratings, and all the associated information. So I've already gone ahead and loaded some of this data into a local SQL Server instance. So I'm just going to show you some of the data so you get a handle of what it's about. So I've loaded 4 tables. The first one is called title, and this kind of shows you the type of the entry. So there are movies in here, TV episodes, TV series, video games, loads of other stuff. And so it gives you the name of the movie, the year, and any genres it's been applied to. Another table I've got is the ratings table. So if I go into that, all the titles have a unique ID that begin with TT. So this is the primary key of the table, so to speak. And then there's a one-to-one relationship to the ratings table with the same ID number. So if people have been on and voted and given a rating to these things, it gives the average rating and the number of votes. The other table that's I've loaded is the principal. This could be the actor, the director, the screenwriter, and so forth. So this has lots and lots of different people's names in, and it has a unique ID for the principal, for the name, and it also gives you the titles they're most known for. Now, obviously, an actor can be in many movies, so there needs to be kind of a table in between title and principal, and that is this title principal table, so it gives you the movie ID or TV show ID, the actor's ID, what capacity they're in the movie, and then sometimes it has the job filled in, and then if they're an actor, it has the character. And this is a array because obviously a person can have more than one role in a movie sometimes. So I'm just going to show you the counts of these tables because it is a big data set. So the number of titles we have is 6.5 million. A million of those are rated in some form. There are nearly 10 million principals, and the linking table has 40 million entries. So if you were to load all this up into Power BI, first of all, on my machine at least, it takes about 5 minutes, and then you end up with a Power BI desktop file that's about 2 gigabytes in size, and that is obviously no good for publishing, and it can be slow when you're working within the data set. So I'm just going to do a little bit of analysis on this title table, and you can see that of the movies, there's about 500,000, and they span a range of 1894 to sometime in the future. I've not done any cleansing on this data, and I don't know how valid these maxes are, but certainly we don't need to bring in the history. So I think what I'm going to try and do in Power BI is to restrict all these tables to bring in movies that are after 2015. So that should bring us back, yes, 95,000 rows. Unfortunately, within the data set, it's pretty comprehensive. There's lots and lots of movies, and a lot of these are very marginal, not very good data. So I'm also going to do a restriction on the movies that have more than a certain number of votes. So I'm going to look at the ratings table, and I'm going to filter the movies also by the ones that have perhaps 100,000 votes. So that should narrow down the data set quite significantly. So I'm going to jump into Power BI and start doing that for you. So it's opened up on the wrong screen. Bring it over here. Okay. So I'm going to jump straight into recent sources and pull up this data into Power Query. So we've got these 4 tables I've described. If I were to hit load now, it would load them in their entirety into the Power BI model. That would take a while, and then we don't need to do that. We're going to apply the filtering first. So by hitting transform data, it takes you straight into Power Query. We're going to be on import mode. And it's over here. So there we have our 4 tables. By default, it takes the database schema and the table name as the object name within Power Query. So we're going to filter by using parameters, so we need to create those. So you can do that under the manage parameters and create a new one. So I'm just going to call this year, and the description, although not really used in Power BI desktop, it is exposed up on the service. So it's important you put something good in here. So I'm going to put the year from which we are loading movies, and then you can do a default value, make it a number, say 2015. So that's creates the parameter there. We're going to do a similar parameter for the number of votes. So we're going to call it the threshold for movies to load, and then we'll say 100,000 votes, and we'll put that in there. So that's great. We have these parameters now. What I'm going to try and do now is build up a separate table that will allow us to filter these other objects. So the first one I'm going to do is the title. So I'll just duplicate this, and then we can apply the filters. So I'm going to hard code the movie filter in. So we'll just say just interested in movies. And then on the year, I'm going to apply another filter saying greater than or equal to. And then this option here allows you to change from a hard-coded number to a parameter. So you can choose parameter, and it's automatically selected year. So now it's going to filter this table by movies that were on or after 2015. And at this point, we don't need these other properties. So we can just right-click here and remove the other columns. And I'm going to rename this to title filter. Now, at this point, this is just the movies that are after 2015. We're also interested in the ratings. So I'm going to do something similar here for ratings. I'm going to call this rating filter. And then I'm going to filter the number of votes greater than or equal to, and again, we've got the parameter already set up. And this will give us only those titles with the more than 100,000 votes. Now, at the moment, these two are separate, and what we need to find out is the ones that are in both of these lists. So a way to do that will be to click on the title filter, and then we can join into the rating filter. So inside Power Query, we use merge queries to do that. And if you just select the merge query option, we can then tell it we're joining from the title filter into the rating filter. And we're doing that on title ID to title ID. And if you make this an inner join, it'll only pick out the ones that are common to both. And it's already telling me there's only 270 movies that have more than 100,000 votes, which is the ratings filter, and after 2015, which is on the title. So if I OK that, up until now, the Power Query engine has been able to derive a native query that runs against SQL Server. When you do a merge query at this point, it disappears. So it can't do it, but not to worry. If you click on this button here and bring in the other columns from the ratings table, and then just hide them straight away, the native query comes back. And we can click on that and we can see it's applying the logic we've asked for. We've got the movies after 2015, and we're also doing an inner join, so the ratings table has more than 100,000 votes. And we can even run this on SQL Server, and I'll just briefly give you some tips on indexing this thing. So if I run this query now, it comes back with the 270 rows pretty quickly, but you can imagine in a larger data set it might be slower. And the execution plan is telling us that it's doing table scans, which is pretty much the worst of the worst. At the moment, there aren't any indexes or even primary keys in any of these tables, but it's recommending we create an index on the title type and the year and bring back the ID. Now that's pretty reasonable. So I'm going to just go ahead and quickly create that. Apologies for my poor naming convention there, but there we go. And this only takes 10 seconds or so. There we go. So now when we run this query again, we will see it's doing index seek, which is pretty good. But on the ratings table, it's still doing a scan. And similarly, it's recommended we have an index on the number of votes and bring back the title ID. So we'll go and create that as well. So that's done. And now when we run this, it's running much quicker, and we've got 2 index seeks, and that's pretty much as good as it gets in terms of indexing. It's important to consider that because we're going to be using this title filter table to apply to these other ones. So if this runs quickly, then the rest of your refresh should run quickly. I'll minimize this now. So we no longer need the rating filter, so I'm just going to exclude it from the load so it's not exposed to the model, but we still have the title filter. So we'll apply it onto the title table, and I'll just rename that. And again, we're going to do it exactly the same. We're going to do a merge query, but this time from the title table into the filter. We'll do it by title ID and make it an inner join. So now this title table will be filtered by the movies we're interested in. So if you OK that, at this point, Power BI will do some internal processing, and it can take a little while on bigger tables. On this one, it's not too bad. And again, you'll lose the native query unless you expand this, and then we can remove the column because it's not needed. So there are only 270 rows in here, as we were told before. So that's filtered the titles, but it's not filtering these other ones. So we'll just do the same thing on rating. We'll merge queries, And again, we can use the title filter table. Make it an inner join in exactly the same way. Expand the join table out, but then remove it. So still, we're going to have a native query that's going into the ratings table, but is applying that same logic from the title filter table. Okay, the next one is this join table, title principal. Now, the process is exactly the same, but if I were to do this now, the internal processing takes about 2 or 3 minutes. So to save you the hassle of doing that, I'm just going to manually amend the M code so that it does the join, expands the column, and then removes it in exactly the same way. Okay, so now this title filter table is also sorted out. So we'll do title. At this point, we have a slight problem because you want to filter the principal table, which has all the actors in, but it's a different ID number. It's not the title ID number, it's the actors. So we need to create a principal filter. So to do that, we can just take a copy of this one here. And when it pops up, essentially we need a unique list of the principal ID numbers. So we can remove the other columns. And then we can make it remove the duplicates. So we can call this principal filter. And then in exactly the same way, we can apply this onto the principal table. See, it's doing some processing here, but it shouldn't be too bad. Okay, so now it's allowing us to go ahead and merge it, principal table, into the principal filter by these ID numbers. And again, the inner join will apply the filter. So you can see I was doing some processing here. This only happens at this point in the modeling. Once it's complete, it shouldn't happen again. So we expand out the join table to get the principal ID, and then we'll just remove it. Great. And the really good thing about this is you can view the query, and you can see it's pushed everything down. So it's got the filter table for the movies, and then it's applied the distinct principals, and it's applied, and then it's joined that onto the principal table. So all the work's been handled by SQL Server, and no point are you having to load in these big tables into Power BI. Or Power Query rather. So these filter tables have done their jobs now. So I'm just excluding them from the load. Even though they're not exposed to Power BI, because these are the tables referenced them, they'll still be refreshed in a normal refresh cycle. And now I can close and apply and get that into Power BI proper. And you can see now we've brought back the 270 movies and all the associated principals and title principals. We should check the relationships have been detected correctly. So we can see now we've got title, principal, title, ratings. So that's pretty good. There's a one-to-one relationship between ratings and title, which we knew. And there's a strong case to bring these fields into this table. We have the principals or the actors over here and the table that joins them together. Now, it is conceivable you're going to want to know the movies from an actor or the actor from the movies. So we're going to set the cross-filter direction to be both. So if you select actor, it will give you the right movies, or if you select the movie, it will give you the appropriate actors. Okay.
Just a question. So you've set the year to 2015 as a parameter. Now that you've got all the data through, is there a way we can change that or amend that?
Yes, so under the transform data option here, you can click on edit parameters, and it gives you the options here. So if you want it to be 2010, you can just change it like that. OK that, and then it's said there are pending changes. So if you do apply, it will then reload the entire data set, and that filter will propagate through all these other objects.
OK, so you don't need to go back into the editor to have to update those parameter values.
That's correct, yeah.
Brilliant, thanks.
OK, so to show you this in action, I'm just going to create a quick dashboard. So I'm just going to bring in the table, bring in the title of the movie. OK, we'll do it that one. We'll bring in the rating into here. I think it will try and summarize it, so we'll just turn that off. And if we start descending on the rating, you can see the most popular or the most highest rated movie we have in this data set is The Mountain 2. Can't say I've heard of it. And then also might be useful to see the number of votes attached to that. And then with the cross filtering we've applied, we can also go the other way. We can also ask which is the most popular or the most highest rated movie by actor. So on the Power BI Marketplace, there's a text filter, which I've just got the file for. So I'll just load that in there. So this is a custom visual. And if you bring in the principal name, it'll then allow you to type and search for that. And I'll just bring that into here as well. So this is a list of all the actors. So if you're interested in Tom Hanks, you can put Hanks in there, and automatically it's filtered by all the Hanks. But if you click on Tom as well, it'll give you his movies. And now where we have the parameters in place, we might be interested in the wider date range perhaps. So we can go, as I showed you before, we can edit the parameters. Perhaps you're interested in 1980, and perhaps we're going to consider every movie with more than 10,000 votes. We can OK that and apply it. And now the data set's getting bigger and bigger as we kind of loosen the criteria here. So of all Tom Hanks' movies, Forrest Gump has come out the highest rated. And if we remove the name filter entirely, we can see in this date range, I think it's still filtering by Tom. Here we go. Yeah, the highest rated movie in this date range is Shawshank Redemption. And you can click on that, and the cross filtering works this way to show you the people that were involved in that movie. And then if you wanted Morgan Freeman, you can click on him, and then it goes back the other way, and you can see all of his movies. So that is a quick example of how you can use parameters to streamline the data flow. All the filtering we did inside Power Query applies to all the tables. So we're not loading anything into principal or rating. We're not loading anything in that's unnecessary. They are all part of the movies that we've selected. Now, in this example, it is the IMDb database, but you can imagine a bigger fact table you might be working in with the business data in there. It might be really big and it might take a while to load in Power BI, or you might be doing analysis on a given year. So applying filters in this manner will allow you to just bring in the data you need for that particular piece of analysis. Of course, you could go into SQL Server and apply a view or something that did the same filtering, but then you might not be in charge of that. So if you can apply the filters in this fashion, you can decide yourself what data you bring into the model. And then if you've done a piece of analysis for a particular year or date range or a particular subset of data, you can easily change that, refresh the report, and your analysis expanded or changed. The other big benefit of this approach is you might not want to spend ages loading a Power BI report up onto the service. So if you set the parameters to be a really narrow range, you can have a really small Power BI desktop file, publish it to the service, and then in the data source settings on the service, you can then expand the parameters, and you can also change them on the refresh cycles as well. So you can choose the parameters on each refresh of your report.
A question here, Lewis, from one of the users, regarding the impact on performance when using the both directional relationship in the model. Just wanted to put that to you. Is there a negative impact on the performance doing it that way?
Yeah, and I have to say I'm not entirely sure of the technicalities behind this. Perhaps you could expand on it, Shep. In my experience, I wouldn't do cross-filtering in both directions unless it's absolutely necessary. And in this example, we do need to do it for the principal and the titles because we want to be able to filter both this way and this way. I think there will be a performance impact, but I don't know how to quantify it.
Yeah. So I think because you've pulled in the data directly from the IMDb source, it's not in the sort of ideal format for Power BI to consume, and we covered that in last week's session in creating an ideal data model for Power BI. So ideally, what we would do is to create this into more of a star schema. We have brought it already into SQL. Then from SQL, that's in a relational database format. What we then do is then put that into a data warehouse schema, into a star schema, and create more of an efficient model from there. So I think because this data is directly from the IMDb, we've used the cross-directional to get the filter working. But that question from that user, yes, it will have a negative impact if this is the way it's kept. But for it to be more efficient, you'd model that as a star schema for Power BI to consume it in a better way. Okay.
Yeah, thank you, Chef. So the only other thing I was going to mention is that is the end of my demonstration. But I think in the subsequent one, I'm going to expand on this example. Under the movie section here, the data isn't normalized, so obviously a movie can be allocated to several genres. So I'm going to show you how to create a slicer that allows you to pick all the comedy ones out, perhaps. And then on the actor side of it, there's a column with these known for titles, which is the movie ID, of which the particular person is most known for. There's 4 of them in general. And so then we'll be able to create a slicer on that. This would break the filtering that I've already applied. There could be movies in here outside of the range that I've filtered by. So you have to do some clever stuff to kind of incorporate that.
Brilliant. Yeah, we'll look forward to that. Thank you very much for that, Lewis. Just whilst we prepare for Ben, just quickly going to share you the process, I guess, that we take, that we're taking here with the Power BI Lunch and Learn. So this is running in its first season, and Power BI Lunch and Learn has 6 episodes running every Wednesday at 12:30, and again run by us 3. What I wanted to bring to your attention is that we are having a season finale on episode 6, which is the 27th of May, and we are having a live prize giveaway as well. Now these will be based around the best questions, so we do get an export of all the questions that are asked during each of these sessions, and the best questions will win a prize. We are creating a random generator in Power BI, which we will run live in the last session as well. There'll be a prize for that. There'll also be a prize for the most attended person. We also get a list of attendees and the times those attended as well. So we will be giving a prize for the person who spends the most time with us on these calls as well. And there will be sort of some best-selling books and T-shirts and more that we'll be giving away in that final session. So please get involved, get sharing this content, get social, help us make this the best Power BI web series there is out there. Okay, I'm just going to prepare for Ben. I'm just going to have Ben, if you could share your screen, that would be fantastic. And I will add that content to be shared in a few moments' time. Ben. Ben, are you there? Oh, yeah, very good. Excellent, right, okay. Yeah, Ben, you are now live, if you'd like to take away.
Brilliant, thanks Sheb, and hello everybody. So my name is Ben Howard. I'm the one who has the parachute. I don't know why I have a parachute on the little icons, but I have a parachute. There we go. I'm going to talk a little bit about shape maps, and this originally came into place because of COVID-19. I was creating a Power BI report for that. So firstly, kudos to Nadia, who sent me whose Power BI report kind of I helped out with and looked at the shape maps. Secondly, of course, it kind of goes without saying that those of us, you know, whose families, we've all been impacted somehow by COVID-19, and even though we're doing Power BI around this, let's not treat this data lightly. And our thanks go out to those people who are keeping us safe, keeping me in food, and keeping the NHS going, and the care workers, and all of the other people. So that's that. So I just wanted to say that. So let's just talk about shape maps. I've got a few slides and then we'll get into the demo. So what do I think about shape maps? Well, this is a typical map that we'd see in Power BI. And of course, it's a kind of bubble chart or a bubble map where the size of a bubble represents the size of something. And in our case, it's confirmed COVID-19 cases. The issue that we kind of have with that is it's complex, it's difficult to see. This type of map, a shape map where we color in areas, can be easier for us. So here we're obviously just looking at England. I'm going to point a couple of things out on this map straight away. So down here you see that Cornwall isn't colored. So that would kind of lead you to believe there's no data for Cornwall, yet there is data for Cornwall. And so mapping data onto maps can be complex, and so this is just the kind of standard map that we've got. Next, I'm going to say that colouring the map can be a challenge. So ideally I want a map that looks a bit like that, but out of the box it kind of comes a bit like that, which that makes no sense to me at all. Okay, so we need to sort the colours out. We also then need to begin to declutter the map, and I kind of try and declutter all the visuals that I've got. So if we look at that map versus that map, the map on the left has some colours around the kind of mountainous areas, North Wales, Galway region here, etc. If we look at the map on the right, we've decluttered that information. So again, when you're bringing and creating Power BI visuals, think about how you can declutter this. And then finally, we need to think about, you know, the number of shades. What looks better? That map actually consists of 4 shades, which is what I'm going to demo. This one actually consists of 10, the one on the right. So that's a little, perhaps it depends upon the amount of data and the grades you want to display. Okay, so ultimately we're going to go from here to here in this demo. So let's just do that. So I'm going to open up Power BI. You can see I've got a bit of a template here, and if I click on and open up Power Query, this is where I need to thank Nadia. This is the CSV file that Nadia gave me access to, and it's a CSV file that anybody can access. So I've downloaded that, and you can see that this comes in as a web query. So literally this was a news source, and in here it was web, and then you put in that URL. What does that look like? Well, let's just open that up in Excel, because you should always have a view of the data that you've got. So here's the CSV file in Excel. I'm just going to turn that into a table. And we can see that we've got some area names up here, we've got some area codes, we've got some area types, we've got nation, region, upper tier, local authority. So that's kind of what we're going to use. That's the upper tier local authority. For those of you who've dealt with local authority data, that's how the UK is mapped out. We've got a specimen date, and then we've got some daily lab confirmed cases, and we've got cumulative lab confirmed cases. I'm interested in the cumulative lab confirmed cases. That's what's going to appear on my shape map. Okay, we can also see, if I just have a look at the date, then actually this is just an ongoing file. So we've got all the data in here. Okay, so I'm going to want to get rid of that. So that's my basis file. Well, that's the basis file, and I wanted to show you that. So we won't bother saving that. If we have a look at what I've done so far in Power Query, then obviously I've loaded that file in. There it is, coming in from the source there. Power Query, of course, then promotes the headers and change some types. I then did a couple of things just to begin to map data onto the shape map correctly. And this is a bit of trial and error. But the shape map, for example, doesn't recognize, for example, Hull, comma, city of. Okay, it's the wrong sort of format. So the typical cleansing that you would do in Power Query, I'm doing here. So it's Hull, city of, and Herefordshire, county of. It didn't recognize that, and Cornwall and Isles of Scilly, it didn't recognize that. So you can see that I've just replaced Cornwall and Isles of Scilly with Cornwall. So again, you know, we work with the data we've got, and that's what we've got so far, and that's where we are here. The next thing that I'm going to do, and we'll just go through the Power Query piece of this, is I'm only interested in the upper tier authority, so we'll just filter on that. And I'm also only interested in the latest date. So I'm going to apply a date filter where we just get the latest date. I don't want the cumulative ultimately for every day. I just want the latest cumulative. And that should and does indeed filter out our rows. So you can see at the bottom here, we've only got 150 rows. We could also just get rid and tidy up, of course, some of these fields now that we don't need. So we could get rid of this, that, and that will do us. And this one we will rename just to be cumulative. And because I'm not very good at spelling, I'm going to change the properties to be CV. CV data will probably do it. Okay, and that should be my query, and that's the only query that we've got loaded in. So let's just close and apply that, and then obviously we'll refresh in Power BI. All right, so let's have a little play. The visualization here is just our normal map. So let's take the area name and stick that on the location and see what we get. Now, I love Power BI, much as I do, but I do like the fact that I can go down to here in New Zealand. I can pick up Bournemouth, Christchurch and Poole, and obviously in the US I pick up lots of stuff as well. So we kind of need to fix that in the first instance. We'll also, though, we can have a look at how this looks on a shape map. So this map here, it's the field map effectively, not the shape map, and you can see that's done a better job in truth of picking up the data, and we should be able to just zoom into the UK here, and we can see that that's actually not too bad as that comes in. So I'm missing a bit in Norfolk, not sure why that would be, but that's our basis for this area map. Now, if I was just to take cumulative data and throw that in the legend, then what I end up with is obviously the latest unique value for each of these. So it's difficult for me to see where the areas that have the least outbreak or the least number of confirmed cases versus where are the ones with the most. It's plainly not obvious, and I would have to go through the key here. So 16, for example, wherever the blue is there, that will be the one which has the least. So let's go and have a look at that data and just see what we've got. So here's the cumulative info. So we do go from 16 cases cumulative in one area to over 3,000 in another area. So what I want is some smart way of just grading this map so that it begins just to have shades of whatever color you want. Now, in my case, I'm going to choose red. Now, we also talked about just cleaning this map up a little bit. So in terms of this map, we can choose the map style. And you can see I've got some different map styles in here: road, aerial, dark, light. If I choose grayscale, and we zoom back in slowly to the UK. Okay, then we've got rid of the roads, we've got rid of the the green bits of North Wales, and actually we're better able to zoom in and home in on the data that we're interested in. So that's kind of the first job. The next bit is to really automatically grade this, because think about it, this CSV file is updated every day, and so of course I could just publish this and I want to load it up and I want to have it automatically coloring regardless of whether these numbers change. So at the moment in the map, of course, I could come in and manually modify the data colors. So if it's 16, I could say, hey, I want that to be red, etc. I want this to happen automatically. So to do that, we need to use a bit of DAX to create some measures. The process really is that I will look for the minimum value in this cumulative field. I'll look for the maximum value, and then we'll work out the range between the two. And that gives us the ability to chunk the data up. So let's just go and create a new measure. And if we just stick that up there, I'm just going to say this is the min value. New measure. Now I'm also getting notes that my network quality is bad. I've got to say I'm on Virgin, and we've had lots of issues with Virgin networks recently, so stick with me and hopefully just follow this through. So I'll take the min value, the min cumulative value is going to equal, we'll use the calculate function here, and I'll take the min, and then we're going to choose the column, which is CV data, and it's cumulative. Okay, and then of course we want to filter that, or effectively remove all the filters, so that we get the minimum value for the data, which, as we've said, should be, if we scroll back to the top here, 16. Okay, so let's just go and have a look at here. Here we've got a multi-row card. So let me just throw the minimum value onto the multi-row card, and we see that that comes back with 16, which is great. So we can do the same sort of thing for the max value. So if I just highlight min value, and because I'm lazy, we can copy that, create a new quick measure or a new measure. Max value equals, get rid of that. And that should be very nice. So we've got the minimum and the maximum. Oh, max value doesn't like the extra piece there. Okay, what have we done wrong here? It's always these. CV data cumulative, let's just see if that plays now. Okay, that's better. So let's put the max value into here as well. Okay, so that's good. Now, of course, you could combine all of these up. I then am going to want to know what's the difference between the minimum and the maximum, because I can't assume that I'm going to start at 0. And so we can create a new measure again, which is just, in this case, I'm going to call it the spread. It's really the range or the spread between the max value and the min value. So we just subtract one from another. Let's just put that in there so we can see that. So the spread is 3,227. Now, what we then want to do is, again, we need a new measure which says how many segments or how many gray shades of red do we want to show on our screen. Now I'm going to choose a quartile, what I call a quartile value. Okay, and so then I'm going to divide the spread, okay, by however many shades. So I'm going to choose 4. If you wanted 10 shades, you would choose 10 in this instance. Okay. So again, let's just put the quartile value on there. And it's about 806. So, you know, that's kind of how I'm going to split the data. So that's all okay. Those are individual measures. What I then need to do is I need to say, okay, where does this cumulative value? So if we look at Worcestershire, okay, it's got a cumulative value of 1072. So is that the very light red, the medium light red, the slightly darker red, or the really dark red? And so we have to create a calculated column that really divides this cumulative by the quarter value, or the quartile value. So let's just do that. So in column tools, in fact it's here, we can create a new column. And I'm going to call this quartile number, if you like. And that's going to equal, and then I can do divide. And we'll take the CV data, and we'll take the cumulative value, okay, which is of course that value there. I'm going to subtract from it the minimum value, so the first minimum value, because again we can't assume we're starting from 0. I'm going to divide that by the quartile value. So again, CV data quartile value, and let's put a bracket on the end of there to match that up. I always just quartile value, that's okay, and that should work. Now we haven't quite got there yet because this gives us kind of 1.3, 1.2. So I've still not got sufficiently round numbers. So we can use a function called roundup, which will really give us a whole number. So if we take divide and we choose round up, then we say we want to round up effectively to the next whole number, which is the comma 0 there. Then we'll get a whole quartile number. Okay, so this should be kind of 1072 is in the second set of data, and we have quartiles from 0 through to 4. And 0 is of course the very first one. So I actually got 5 quartiles, but 0 we'll get around that. So that's okay. That's our data. So now we can go back into our lovely map, and that looks like this. Let's go and now play with the data colors for the map, or rather initially play with the legend. What do we want on the legend? Well, we don't want the cumulative value anymore. Actually, what we want is the quartile number. We'll have to get this map not zooming, of course.
5 minutes to go, Ben.
Thank you. Okay. So now you can see we're displaying 4 values or 5 values, 0 through to 4 on here, and it's simply a question of saying, okay, well, we can probably bin the legend because that doesn't matter for anybody. Oh, for goodness sake, I nearly swore then. There we go. Right. Note to self, don't change that map again. Okay, and then in the data colors, this is dead simple. We've now only got 5 data colors to pick from. Now, as humans, we're good at, all right, let's change all of these. So 0 and 1 are going to have the same one. 2 is going to be slightly darker red. 3 is going to be slightly darker red. And 4 is going to be dark red. Okay, I'm not going to change this again. I'm just going to zoom in now. So now you can see we can easily, in fact, we can easily visualize the kind of COVID-19 confirmed cases hotspots that we've got. When I download my data tonight and I refresh this for today's data or tomorrow, of course, it's going to go through the same process and again show me the different areas of hotspots. So that was really all I wanted to show you. You can make it more complex than that. You can use more gradations, etc. But the point is that you're not recolor coding this every day as your cumulative values really change, because in a hotspot map like this, we're not interested in the actual cumulative values. We're interested in the relative values between one area and another. All right, Sheb, that's pretty much me done. If you want to take it away.
Excellent. Thank you very much, Ben. Appreciate that. I've got a couple of questions for you, if that's okay. One was around the zooming. Is there any way to stop it? But I think that's something that we might need to look at.
Yeah, I think that's in the format, whether we auto zoom or not.
Okay.
Yeah. I'll have a look at that while you look at some other stuff.
Okay. And the other one is, can we do binning instead of using groups?
I did look at that, and I can't remember the answer because it was a few weeks ago when I looked at it. So I don't see why not, unless somebody else has a hard and fast answer.
Not from me at the moment. But if what we'll do is we'll look at that, and we can send that out in some comms as well, if we do find any difference.
Yeah, the issue is you choose the size of the bins, don't you? And so you'd have 0 to 10, 10 to 20, 20 to 30. And the issue is, of course, that we're growing our cumulative number of cases each day. And so, you know, what happens when you get another bin on the top? You're going to have to come back in and modify the colors for the relevant bins here. So I don't know, but
okay. Could we conditionally format to use the defined colors of the quartiles?
No, I don't think you can. No conditional formatting up here in any of this little lot. Maybe you could do something smashing with some DAX, but no, this was a way that just worked for me.
Okay. Brilliant. Thank you very much, Ben. Let's move over to next week's session. So episode 3 is coming up next week. So here we are, episode 3, Wednesday, 6th of May 2020. I'll be presenting Sheb, and I'll be doing Power BI exception reporting, handling errors and exceptions in your reports. So there are ways of improving data that you import from your source systems, and to continually monitor that and update that, so you always have a clean and updated data set. And it's something that a lot of companies benefit from. So we'll be going through that in one of the sessions, and Ben will be going through another topic that we will decide this week and announce before the end of the coming week. Okay, so any comments? Yes, thank you everyone for joining. Appreciate you taking the time out to spend your lunch with us. As we've said, we will be doing a prize giveaway, so keep attending, keep coming, keep giving us all these questions. We've had some great questions today, and we'll be, we're sort of doing all these sessions for yourselves, and we want to give back to you as well, and which is why we're doing the sort of prize giveaway for you guys. I'm just going to hand over to Alex just for some closing notes, but thanks again, and catch you guys soon.
Thank you very much, Sheb. Thanks to Lewis and Ben for today's season 1, episode 2. I hope you enjoyed both talks. So if you come on to talk late, please use this link again. You can play back the whole session to your heart's content, and we will be sharing the URL to an open drive for all the slides and the topic talks today. Tomorrow night we've got Power BI Use Group at 6 p.m. So I'll send through a link tomorrow to everyone that's attended today. If you haven't already RSVP'd by Meetup, we've got Rishi and Laz, so it should be a good session. But again, thank you very much to Sheb, Ben and Lewis. We'll be back same time next week, 6th of May at 12:30 for exception reporting and Ben's topic to be confirmed. So thank you very much. Enjoy your rest of the day and take care.